Yeah, I should just doesn't matter. Okay. Series rule primary exception. No built-in, no exceptions, no RTTI, no omit frame pointer, no online tables. This is M32, MX32. Okay, MX32. Which means we should be able to libs. Alright. Then we need to make install string, okay? Don't do anything before we have finished the installation. Please don't do that. All in the install. All the build system will try to rebuild and not going to install the things what we would expect. Alright. Now it's a quite funny situation. It's very funny, this situation, okay? Is that 64-bit is installed 64-bit here. 32-bit are not installed, but X32 is installed here. Okay, which is totally ridiculous, right? We're not doing that. Why do you do that, right? So to fix it, our job haven't. I don't think our job are done. Okay, so of course we first need to copy this linker script out, LD scripts out again, so we don't get in troubles here. Okay, so let's go to the lib. Let's just move lib to lib2. Okay, we don't have lib anymore. We only have lib. Okay, we only have lib. I'm gonna enter lib here. We copy LD scripts here. Now to the lib. Then what we're gonna do is that it has 32, right? It has 32. We just copy all the libraries after that. After 32, we use this data modified. Okay, there are 32-bit libraries, right? We delete every file besides, or we don't delete any file. We just copy it again. Copy lib2 to lib3, including prevent we have encounter issues with ourselves. Now we have lib2. Lib2. Okay. Delete every file before 1429, right? Which is the libraries we installed before. Delete all of them. Just delete. Including this X32, we delete all of them. Don't do that again. Skip. Okay. We can just do it later, but this is quite ridiculous. No. Okay, we go to lib2. Remove LD Linux. Remove it. 32, X32. Now we get only 32-bit libraries, right? Remove this lib2 all the files to lib32. Okay. So now we should be able to have the library that's correctly installed here. Yeah. lib2, lib3. Okay. More. I love to put death. Okay. Put all the garbage to death. Lib2. It doesn't matter. Okay. we should also put GCC calls to death. Okay. Now we have a clean installation. Let's just try whether all the libs are set up. Okay. We try L3. Don't try CSDIO. Okay. Try L3 because we don't know whether the entire thing works. No, not this, right? It should be Ubuntu Linux. A.C. No problem. M32. No problem. Oh, wow, it cannot find libc++ anymore. This is absurd, right? This is absolutely absurd. Right. Let's just wait again. You can find x86, but it cannot find 32. Okay, it cannot find 32. We can see it cannot find that. Right. Lib32 is just completely ignored. Just completely ignored. Even when I put a lib here, it doesn't work, right? This also this. So to fix that, we need to move these LD scripts to lib32. Then remove lib. Okay, remove lib. Then move lib32 to lib. Okay, we should. You should install all the library correctly as what we need right now. So lib is lib32. Okay. Yeah, x32, no problem. M32, no problem, right? So yeah, that's entire library part. We can copy entire directory to. So we don't need to do that again in next part. Right, this is quite funny, right? We remove LD script. Remove this directory. Then what we're going to do is that we're going to. Oh, okay, we also copy the directory, include directory to here. Okay. Copy the directory here. Now we have a libraries for Canadian libs. Okay, now we can start our Canadian compilation. So we also put a Canadians to this. Okay, everything is this. We're gonna install that directory here in the Canadian directory, right? Canadian. So what we're going to do right now is that we're going to compile. Our final goal is to compile Linux programs on Windows. So we're going to copy the directory, all the Canadian libs here. Here. Oh, I forgot it again. It should be copy R. Right, now we have Canadian libs. We move Canadian libs to rename it as x86 64 Ubuntu Linux GNU. Okay, now we have the headers and all the libs. Okay, although we contain all the shell libraries, the symbol link. We need. Let's get started. We port it. Okay, we can start port. See any updates? No updates, and we're gonna stop. Yeah, we're starting. We start here. Canadian. We go here. We cross. I don't need cross, right? Because if the triplet is different, I can just differentiate that. I don't need to actually do anything. Let's just as what we would do before always. Target, right? Host. Don't forget, so these two portions must be contained both, right? You must have both of them in the path, right? You must have Linux GNU and the x86 64 portion we just compiled in the last video, right? So the last video, because I can just render a passive video here. You just see that in the playlist, it doesn't matter. In the YouTube's playlist, it doesn't matter. So we're gonna prefix whole target, right? Target. Let me see. It's here. It should be here, right? Canadian. Yeah. What? This is wrong, right? It is just wrong. You don't include here. Okay, probably I messed things up, sorry. Let's just copy it again. Copy the Canadian labels again. Oh, we already have this directory. We don't care, we will delete it. We copy all the Canadian libs. CPR to here, right? To here. Not yet. Close it. Okay, we do the prefix here and host target prefix. Then we're gonna stop. In YouTube, GDB, disable NRS, disable error, enable go. Okay, target can give go. Host equals host target prefix. We can echo it before we do any compilation here. Yeah, doesn't look like any issues with it. Actually, Windows provides a thing here, which is test sensitivity with the FS utils. So I think I need to put entire directory as case sensitive. Yeah, it deletes the previous installation I have here. Enable. Okay. When you disable enable sensitivity, although the file system itself is case sensitive, the Windows doesn't work this way, which is quite funny, you know. Yeah, if you want icon V, you can use icon V, right? But here we're not using icon V, right? Using icon V has a good things that you can put whatever things you want with execution chart set. But right. Yeah, that's it. There's just nothing else. JIT. All right, we have the utils. Oh, that's bullshit. I shouldn't put here, right? Should put in the GCC subdirectory, a bin util subdirectory, right? So let's just see what our Canadian compiler, what they set up with all the things. Yeah. Nothing. We're gonna just compile GCC, right? We can port it again. We port the GCC again. Ensure we have a newer installation. Okay, it's the latest one. Then we just get it from our cross compiler. Okay. Replace all the cross with Canadian. Replace all the cross with Canadian. Then add a host here. Okay, we just add a host. Oh no, it's here, right? No, it's one more subdirectory. So now GCC will do is that it will use x86 W64 mean GW32 to build a compiler part using x86 64 Ubuntu Linux kernel to build the library part, and use our the native G++, GCC and G++ to build the things that build system needs. So it's now using 3 compiler, 3 GCC to build the entire thing. Okay. It's invoking 3 GCC. Okay. 3 different targets GCC, but they are all GCCs with different targets. 2 cross plus 1 native. Put them together. Okay. Don't forget to fix that bug I just mentioned last time with those 2 bugs, right? The second bug doesn't mean if you just install library, it doesn't matter. The first part, FENV bug, okay, is something you have to fix, okay? I'm going to mention again, you have to manually fix it. It's designed, but it's not fixed. People complain about it, but nobody's fixed it. Okay? These people are using GCC 11. It's just 8 months later, ago, just a year ago nearly, right? They're thinking they are using latest compiler, which is ridiculous, right? Which is ridiculous. A bootstrapping. I don't care what the people are thinking about. Better. see. And the compiler part is actually quite slow compared to compile the library. The library is also very slow, right? Because also of sanitize all the things here. Of course, after that, we're going to install libraries again. We have coroutines. It's from GitHub. You know, I don't recommend if you're using GitHub. Better just using things just directly the GCC's source repository. gcc.gnu.git. 6 hours, yeah. Which means I don't have any. It's in the 30. Okay, it's not just. It's 6 hours ago, yeah. Two days ago. 3 months ago. MinGW. OpenAD64. x86 64 W64 MinGW G++. I have no exceptions. I have no RTTI. I have asynchronous unwind tables. Missing format attribute. Overloaded virtual. Pedantic. Pedantic. How to pronounce this? Pedantic.
Pedantic. Pedantic.
Okay.
Pedantic.
Why is so slow? You know? Probably because a lot of processes are running right now. A lot of Python programs, right? I'm sorry. Pedantic. Please be a little bit fast. Please. Okay. src. Table. This is so slow, you know, it's just too many Python. Don't kill this Python. Python, 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 Python. Oh. Microphone is not microphone, but it's sound, right? Sound. Choose your input sound. Choose sound. What? Now you can see it's not using the x86 bound to Linux kernel GCC. It's not using x86 64 W64, nor using the native GCC. Right? It's using another cross torsion to build a library part. X32. C++. Pedantic. Compilation. Python diet. Python is ridiculous. Oh, yeah, I think we should crawl. Crossing Python. What? Huh. GDB. GPL license. Free Software Foundation. FSF. Free Software Foundation. Free Software Foundation. Why is it called Liberty Software Foundation, right? It would be better than free, right? They just called it SLF. I think Liberty Software Foundation would be better than Free Software Foundation. Maybe uninitialized. The value by maybe not initialized in this function. Visibility is hidden. No IP ICF. And we also have X32. Okay, the 3 body leaves here. So many multi leaves, right? The mango. You know, this is quite funny with the thing is that they always have the warning here. They never fix the warning. Right? It's been a warning for 2 years, or 3 years probably. I mean, nobody seems to fix that warning. There's the we should be able to see that in 30 seconds, right? There's that warning here. Yeah, this warning. You know, anytime I see that, I know you are building lib sanitizer, but this warning shouldn't happen, right? Uninitialized variable. It says uninitialized variable. Why? They really need to put a bracket or something like that, right? Offset plus offside size. I see. You know the quality of the LVM, you know. Local IOVC. Yeah, now install script J. Okay. Oh yeah. Done. Okay. The compiler, we build the compiler that runs on Windows. On Windows. Let's just have a try. Have a try on this compiler. So speed go here. Hard. What? DDL. It's probably my previous installation. CVF, okay. go here. Why so small, right? This shouldn't be that small, right? Alright, I think I did not contain all the trash I put here. So copy here. Now what we can do is we just unzip the file here. Oh no, we cannot do this. Okay, we cannot do this. The reason I've said a lot of times is that when we decompress the file, we need to set 7-zip as administrator privilege, or you cannot create symbolically. Create a symbolic link here. Okay, no problem. Now we have the torture here. Still, like, we only need to add this in the path. I have already done that, right? So now we should be able to compile these hello world programs. Okay, let me show the magic here. What does this compiler mean here? Okay, we don't care. Just close it. Don't care. Bullshit. No. So, right, we still open CMD. Then we do it using x86 Linux GNU G++ to see the compilation. Ubuntu. What's wrong here? No, it doesn't have the file here. Probably. We still don't have that. So, which means we're not correctly set up the environmental variable. x86 64. We do have that, right? And why do we cannot find it? Why? Update environmental variables Windows 10 CMD. Refresh. Yeah, I think it's just refresh env whatever. I think, yeah. x86 64 Ubuntu Linux GNU. The only possibility is that we are not setting the environmental variable correctly. Still cannot find it. Can I find G++? Well, we cannot find find it, which is quite funny, right? x86 64 Ubuntu Linux GNU. Why? This is quite ridiculous. Why? Probably, I think we shouldn't just put a new directory here. Oh, probably because we just set the directory as case insensitive. It doesn't work quite well with Windows, right? Oh. Which is quite ridiculous. This is quite ridiculous, right? No C++. Can we just set Yeah, if we just directly do it, we'll be able to find it. But all right, you put exe here. Okay. This is totally bullshit, right? This is totally bullshit. This happens when we don't set, we're not setting, we set the thing here as case insensitive. You will not correctly find out the executable because of exe. Okay, because of exe, which means we cannot do this, right? Delete it. Just delete it. Okay. These are shared here. We have another thing that is accessing here. Which directory? Probably CMD. Or maybe just which process is accessing this? Accessing it. Is this 7-zip just doing that? Or CMD, whatever. Or just VS Code. Onto Linux, yeah, it should no problem. Disable case sensitivity, right? This is just quite funny, right? Just you cannot find. So this is what the case insensitivity is. It's just wrong, you know, just something what Windows does very wrong, right? It's just very wrong. Of course, we need to add administrator privilege, right? So we'll unzip it again. Extract here. Oh no, we are doing that little shit again. So they all need registration. Now we're going to encounter an issue with Linux kernel header file. Okay, which is that the header will we will not know it's not correct, right? The header isn't correct because this is the Linux kernel is doing things that just cover the things up, right? They have the name with same name here. I really hope Linux can do a renaming. You know, why do you do this, right? Just ridiculous using case sensitivity for this bullshit. It's in ID with v4, right? IP v4. So we have a small case of the thing here, and then a case here. So what we can do is that we just manually copy entire file. We can copy the content here, then we remove that another file. Okay, we remove this small TTL. Okay, one is TTL, the other is TTL. Right? The uppercase TTL and lowercase TTL. Copy it, and doesn't matter. We remove this file. Okay, that's it. All the things are done. Oh, there's another file. It's all the same issues, right? Why would Linux kernel do this, right? It doesn't make any sense, you know. Just completely makes no sense, you know. Linux kernel header file is just one of the worst bullshit in the world. It's just ridiculous, right? It's just ridiculous. And remove all the uppercase thing here. ECN. All we can do is just set this directory only as case insensitive, but I hope we don't encounter any issues. Now we should be able to find out the file here. Go to new FD and just compile it. Right, we will find it. So we can compile compile it with this compiler, we're gonna see what's happening here. Whatever, I think I'm native probably not be better, but the CPU is Ryzen 3rd. I'm gonna see. Mark equals Zen 3, right? Okay, Zen 3. We have our hello executable. We cannot directly run it right on this machine, right? But we can do is that we copy this back to the build we just used. Okay. Any directory, we just find a directory that doesn't contain a lot of files. Test the build, whatever. Delete all the bullshit. Let's just use test build. Okay. Delete all the file here. Now, where's my executable? A new FD, right? Okay, we will copy this executable here. Then we run it. Okay, it works. Okay, so we will not compile a Linux executable on Windows. Okay, no joke. This is not a science fiction or anything. Okay, I do that frequently. This not only works, but also works for a lot of other things like sanitizers or other things here. We can have a try. For example, let's try my library, for example, right? Try sanitizers. You can enable sanitizers, whatever you want. It will always work. I think just use this construct fstream from syscall, whatever. Now we're first going to run it with the native version we just built in the last video. Right, we compile it. The first time will be very slow because, right, you cannot find NTDLL, right? Because it just needs NTDLL. We need to put NTDLL here. Link our NTDLL, then we can construct this fstream from syscall. Okay, we can get all the information we need. Notice that Windows also have file descriptor. A lot of people say Windows doesn't have file descriptor, which is wrong. So we can also do is that we just using x86 64 Ubuntu Linux GNU G++, and we're gonna use. We can not use it. We can use linker, Go linker, or not use Go linker, whatever. But Go linker find that it can produce smaller binary. We copy it here and we're gonna run it. Okay, we construct fstream from syscall. It works. Okay, it works perfectly. We even copy this executable, this Windows executable here. See, Windows Linux also have wine, right? You can run it. Gonna show the same thing here, and we can see even with wine you have Win32 handle, VW handle, FD, whatever. On Linux, okay? It gives all the information we need. Quite funny, file descriptor is here. Right, the same executable. Of course, WSL, if you run the executable in WSL, it should also work. But I'm not going to show the fucking WSL. WSL is quite crap. So that's all about the entire video. And it's how you compile. You can compile Linux program on Windows. Okay. So in the next video, we're probably going to show how to build a native toolchain for Raspberry Pi. Raspberry Pi is that it's using ARC64, right? We probably want to do that again. And we can compile. We can then we can build another compiler just cross-compile ARC64 programs on Windows. So today it's building the crossback, which is we compile a toolchain that runs on Windows, but then it produces binaries back to the Linux, which is called crossback torture, crossback. It's just a kind of Canadian torture, right? Just Canadian cross torture, which is, I just like to call it Canadian compilation. This is Canadian cross torture, but here this just Canadian native, right? Just Canadian compiler, right? Happy 2022, right? Just all the things we need. It shows everything what we need, and it shows all the information we need. Yeah. After that video, probably gonna make another video about how to do that with how to do Canadian compilation with Clang. But even with Clang, you need to first do GCC thing here. Okay. So that's about this video, and it's probably another quite long video. That's it. Thank you for Happy New Year. Right?